A stone is dropped into a quiet lake. Quiet lake means there's no wave as such. It is stagnant. And the waves move in a circle at a speed of 5 centimeter per second. I'll make you guys understand what is that. At the instance when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? So let me explain it with a bit of animation. So we can see this is a lake which is stagnant, means there's nothing that is happening to the lake. Now, if I happen to drop a stone, so what happens? We have a wave, right? Something like that. This wave is moving out at a rate of 5 centimeter per second. So every second it is moving forward at a rate of 5 centimeter. So let me put it across to you guys in this manner. Say this is somewhere in the middle. That's just too small actually. Okay, that's better. So basically we are looking at the following. We have the following scenario to be this, and say in a matter of second it becomes this. So this is in 1 second. Now what the question is talking about is the following. So we have, say, this particular, see this is circle, right? From the top we can see that it's circular. So say this radius of the circle happens to be 10 centimeter, and this would be 15 centimeter if the time for this transition is 1 second. Within 1 second it moves from 10 to 15, right? Now if we observe the circle from the top, we can see that circle, the area is increasing, is it not? So it was nothing and it became this and then this and this, so on and so forth. So the area within this boundary, it's increasing. So they want us to figure out what is the area at a particular instance of time. Okay, so we have the quantity speed, the speed at which it's moving out, and the area. So which is the quantity that will link this to? What can link this to? Right, radius, is it not? Indirectly they have given at the rate at which the radius is increasing. When they're talking about speed of this point moving out, they're talking about the radius, at what pace it is increasing. So basically we have ds by dt. We need to figure out dA by dt, and indirectly they have given us dr by dt. So this is the quantity which links both of this concept, all of this concept. Now let's start with the given. So we have been given ds by dt as 5 centimeter per second. We need to figure out dA by dt when the radius is 8 centimeter. The working so we have area of the circle, which we can represent it as A of r, that is pi r square. Now how will we figure out ds or dr by dt? Right, this is the only formula that links all of this, right? There's nothing else. But how to make use of ds by dt? Think over. As I mentioned earlier, it is nothing but your dr by dt. Both are one and the same. As the wave's speed is 5 centimeter per second, this implies the radius of the wave to is 5 centimeter per second. So basically, what are we looking at? We are looking at dr by dt is equal to ds by dt, which in turn is equal to 5 centimeter per second. And now we have EFR, which is pi r square. So we can differentiate EFR with respect to not radius, time. And so we have dA by dt, which is equal to 2 pi r, and this is dr by dt. So this is as per the chain rule. Chain rule helps us to do this. All we have to do is substitute dA by dt at r is equal to 8 is equal to 2 into pi into 8 into, this is 5. So this is basically 4080. Okay, actually pi, area unit is centimeter square in this case, and time is second. Again, if you guys don't write this, you're going to lose half marks. So we'll summarize the answer. The area of the circle is increasing at a rate of 80 pi centimeter cube per second at r is equal to 8 centimeter. And we can underline this. Helps in calculation, correction, not calculation, correction. Please understand the underlying working principle. If you guys understand analysis part in each question, you're pretty much done. You can answer any difficult question. Okay, so you can pause and have a look.